Welcome to this tutorial on inheritance in Python, a crucial concept in object-oriented programming, presented by Study Recnor. This session will help you understand inheritance from the ground up and its role in making programming more modular and efficient. To start, let's briefly discuss what object-oriented programming is. OOP is a programming paradigm that revolves around objects and classes. It allows us to model real-world entities and their relationships in code. Among the four principles of OOP, abstraction, encapsulation, inheritance, and polymorphism, inheritance is particularly powerful because it lets one class reuse the functionality of another, reducing redundancy and improving maintainability. Through this tutorial, we will explore examples, practical use cases, and the best practices for using inheritance in Python. By the end, you will have a strong foundation for applying inheritance to your projects. Let's dive in. Inheritance in programming mirrors inheritance in the real world. Imagine a child inheriting traits like eye color or height from their parents. Similarly, in Python, a child class inherits methods and attributes from its parent class. Why is this significant? It allows us to build on existing code without rewriting it. For example, if you have a general class called vehicle that defines common properties like speed and fuel type, you can create specific classes like car or bike that inherit from vehicle. These child classes can use the parents class properties and add their unique traits. Let's break this down with an example. Consider the base class animal, which has a method speak. A child class dog can inherit from animal and access the speak method directly. This saves us from defining the same method again. Inheritance enables us to reuse code while maintaining logical relationships between classes. The benefits of inheritance are threefold: code, reusability, maintainability, and extendability. First, consider code reusability. Without inheritance, you would need to copy paste shared code across different classes. This approach is error prone and inefficient. With inheritance, common functionality is written once in the parent class and reused in multiple child classes. Second, maintainability is enhanced. Suppose you identify a bug or need to update a feature in your parent class. Changes made in one place automatically propagate to all inheriting classes. This keeps your code base clean and easy to manage. Finally, extendability allows you to add new functionality with minimal disruption. For example, if your application supports cars and bikes and you now want to add trucks, you can simply create a new truck class that inherits from the vehicle class. This is much easier than rewriting or duplicating code. Think of inheritance as the scaffolding of a skyscraper: strong, reusable, and expandable. Syntax of inheritance. Python's inheritance syntax is both simple and elegant. A child class is defined by specifying its parent class in parentheses. Let's examine this with an example. Imagine you have a parent class called animal with a method called speak. To create a child class dog that inherits from animal, you write class animal def speak parenthesis of self, print parenthesis of animal speaks, class dog parenthesis of animal pass. The pass keyword is a placeholder indicating that the dog class doesn't add any new functionality yet. When you create an object of dog and call the speak method, Python searches the parent class and executes the method. This syntax is incredibly intuitive. By simply including the parent class in parentheses, you unlock the power of inheritance, enabling efficient reuse of functionality. Overriding methods. While inheritance allows code reuse, it also offers flexibility through method overriding. This is where a child class redefines a method already present in its parent class. By override methods, sometimes the child class requires a behavior that is specific to its context. For example, the parent class animal might have a generic speak method, but the child class dog may need to redefine this method to output dog barks. Here's how it's done. Class animal def speak parenthesis of self colon print parenthesis of animal speaks. Class dog parenthesis of animal def speak parenthesis of self colon print dog barks. When you call the speak method of an object of dog, the child class version is executed, overriding the parent class method. This allows you to retain shared functionality in the parent while customizing specific behaviors in the child. It's a perfect balance of reuse and customization. The super function is a gateway to accessing methods of the parent class from within the child class. This is especially useful in constructors where the parent class initialization logic is required alongside the child class logic. For example, let's revisit the animal dog scenario. If both classes have an init method, the child class can call the parent's constructor using super keyword. Here the super function ensures that the animal initialization runs before the dog initialization. This is critical in scenarios where the parent class setup attributes or configurations that the child class depend on. Using super consistently avoids redundancy and ensures the parent-child relationship is respected. Python supports 5 types of inheritance: single, multi-level, multiple, hierarchical and hybrid. Each type has its own structure and use case. Single inheritance, one parent, one child. Example, vehicle as a parent and car as a child. Multi-level inheritance, a chain of inheritance. Example, class A to class B, class B to class C. Multiple inheritance, a child class inherits from multiple parents. Example, class C of A, B. Hierarchical inheritance, one parent, multiple children. Example, person as a parent to student and teacher. Hybrid inheritance, a mix of the above types leading to more complex relationships. Each type addresses specific programming needs, and understanding when to use them is essential for writing efficient code. Single inheritance. Single inheritance. Types of inheritance. Python supports 5 types of inheritance: single, multi-level, multiple, hierarchical and hybrid. Each type has its own structure and use case. Single inheritance, one parent, one child. Example, vehicle as a parent and car as a child. Multi-level inheritance, a chain of inheritance. Example, class A to class B, class B to class C. Multiple inheritance, a child class inherits from multiple parents. Example, class C of A, B. Hierarchical inheritance, one parent, multiple children. Example, person as a parent to student and teacher. Hybrid inheritance, a mix of the above types leading to more complex relationships. Each type addresses specific programming needs, and understanding when to use them is essential for writing efficient code. Single inheritance. Single inheritance involves one parent class and one child class. This is the simplest form of inheritance and a great starting point for understanding the concept. For example, consider a vehicle class with attributes like speed and fuel type. A child class, car, inherits these attributes and methods, but can also add unique properties like number of doors or trunk size. This setup keeps the vehicle class generic while letting car introduce specific attributes. By isolating shared functionality in the parent. Single inheritance promote clarity and reusability. Think of single inheritance as extending a tool set. The parent class provides basic tools and the child class refines or adds new tools, making the whole system modular and maintainable. Multi-level inheritance. Multi-level inheritance involves a chain of inheritance where a class inherits from a child class, forming a hierarchy. Imagine a structure like this. A living being class defines common traits of all living beings such as breathing. A animal class inherits from living being and add traits like movement. A bird class inherits from animal and add unique behaviors like flying. This chain allows the bird class to use methods from animal and living being. For instance, a bird can breathe, move and fly. Multi-level inheritance is useful for modeling hierarchies like biological classification, organizational structures or even software design frameworks. However, be cautious. Long inheritance chains can become challenging to debug and maintain. Always strive for simplicity. Multiple inheritance. Multiple inheritance allows a child class to inherit from more than one parent class. While powerful, it introduces complexities, especially when the parent class share methods with the same name. Consider a real world example of a smartphone class that inherits from both phone and camera. The smartphone class combines functionalities from both parent classes, allowing it to make calls, take pictures, and browse the internet. However, what if both parent classes have a method called power on? This is where Python's method resolution order MRO comes into play, ensuring a predictable method lookup sequence. Always be mindful of potential conflicts when using multiple inheritance. Hierarchical inheritance. Hierarchical inheritance involves one parent class and multiple child classes. This setup is ideal for scenarios where multiple classes share common functionality but also require customization. For example, consider a person class as the parent and two child classes student and teacher. Both student and teacher inherit the display info method from person while adding their specific methods study and teach. This approach avoids redundancy and provides clarity in class design. Hierarchical inheritance is common in software systems where a base class offers shared services or data models, while derived classes implement specialized behavior. Hybrid inheritance. Hybrid inheritance combines multiple types of inheritance to form complex relationships. For instance, you might have a mix of single, hierarchical, and multiple inheritance in one program. Let's say you have these relationships. A person class is the parent of student and teacher, hierarchical. A part-time student class inherits from both student and employee, multiple inheritance. The part-time student class inherits from both student and employee, making it a hybrid structure. Python resolves potential conflicts using MRO, ensuring a clear hierarchy. While hybrid inheritance is powerful, use it judiciously. It can quickly become challenging to manage. Method resolution order MRO. Method resolution order or MRO determines the sequence in which real life example vehicles. To solidify our understanding of inheritance, let's dive into real life example using vehicles. The vehicle class can represent common properties like speed, fuel and capacity, while subclasses like car and truck can add specific attributes or behavior. Using the class, we can now create objects for each type and call their methods. This hierarchy simplifies the representation of shared and unique characteristics. Such a structure is widely used in real-world applications like inventory systems, for example, vehicles or traffic simulations. Best practices. Inheritance is powerful, but like any tool, it should be used wisely. Here are some best practices to consider. Keep inheritance trees shallow. Avoid creating deep hierarchies. While multi-level inheritance is useful, too many layers can make the code base difficult to understand and maintain. Instead, aim for a hierarchy with fewer levels that is easy to follow. Use super keyword consistently. Always call the parent class methods using super keyword. This ensures proper initialization and prevents missing important setup logic in the parent class. It also makes your code future proof if changes are made to the parent class. Prefer composition over inheritance. Inheritance represents is a relationship while composition represents has a relationship. For example, instead of making a car class inherit from music player, it's better to make the car class have a music player as an attribute. This reduces coupling and improves flexibility. Avoid overusing multiple inheritance. While multiple inheritance is supported, it can lead to complexity and potential conflicts. Use it only when absolutely necessary. And always test for method conflicts using MRO. Write clear documentation. When using inheritance, ensure that each class and method is well documented. This helps other and your future self understand the relationships and behaviors within your code base. By following these practices, you can leverage inheritance effectively while maintaining a clean, efficient, and maintainable code base. Recap. Let's summarize what we have learned in this tutorial. What is inheritance? Inheritance allows a class to acquire the properties and behaviors of another class, promoting code reuse and maintainability. Types of inheritance. We explored 5 types: single, multi-level, multiple, hierarchical, and hybrid. Each serves different purposes in code organization. Key concepts. Overriding methods lets child classes redefine parent methods. Super provides access to parent methods and ensures proper initialization. MRO determines the sequence of method lookup in multiple or hybrid inheritance scenarios. Best practices. Keep inheritance shallow. Use super keyword consistently. And prefer composition when it better suits your design. Inheritance is a fundamental concept in object-oriented programming that simplifies complex systems. By mastering it, you will write cleaner, more efficient, and maintainable code. Thank you for joining this tutorial on inheritance in Python. We hope it helped clarify this essential concept and how it can be applied effectively. If you enjoyed this session, please like, share, and subscribe to Study Recmore for more in-depth tech tutorials. Let us know in the comments if there are specific topics you would like us to cover. Keep practicing, stay curious, and happy coding.